Welcome to API Days Australia. This is my fourth API Days, I should say. Thank you. Been doing API Days primarily for the last 3 years in Singapore. For those who don't know me, I'm Manjunath. I'm part of Gartner now for almost 10 years. Part of the software engineering practice. You know Gartner for Magic Quadrants, hype cycles, right? That's typically what Gartner is known for. But we use a lot of that learning to make an informed decision about the future. And this is really what this session is about. So we'll be talking about the impact of AI on the future of software engineering. I hope it excites you as much as it does, for me. I want to open with a very stimulating thought. What would you build if you could build anything? And I mean literally anything. This might seem like a deceptively simple question when you hear it, but it's incredibly difficult when you think about it, because you're almost looking at your own imagination as being the only constraint. I'll let you ponder for a bit, because by the end of this session, we'll revisit this question, and you might actually have a different answer to this question. We look at 3 ways that AI is going to impact software engineering. So this is really taking 3 dimensions into view. First is AI is going to impact the way we work. That is, in terms of how we are organized, in terms of how Mehdi described, how people interact with each other. Fundamentally, if you look at what's being described here, AI is not just going to be a tool that developers use individually, but teams are going to use AI as digital partners. The next dimension that AI is going to have an impact on is on what we build. Every single application is going to become intelligent by design. So that's the view we take. But if you think about this, anytime we build intelligent products, we got to infuse trust by design. So think of this as intelligent by design necessitates the need for trustworthiness by design. And in fact, as we go through the session, what you'll also see is this is also how intelligent applications fundamentally differ from traditional applications. The last impact is going to be on how we build applications. So this is, as we have all known, we've loved our infinity loop, which is a depiction of the SDLC. And we believe that AI is going to have a profound impact on just shrinking that SDLC into just one single step, going from intent to outcomes. So we call this zero friction SDLC. Feel free to call it frictionless or whatever adjective you choose. So let's dive right into how AI impacts how we work. Our first position, as in Gartner takes this view counter to a lot of the popular opinion, which is saying, well, with AI you don't need any more developers. You need fewer developers. We take the opposite view. So in fact, what we like to think is, and I'm sure a lot of us, being developers, we would love to hear this. And this is fundamentally, if we have been coding, we would realize that software engineering is not just coding. Just because you have AI assistants that can generate code, it doesn't mean that AI will replace software engineers. In fact, we believe very strongly that you'll need more developers, not fewer. And let's walk through a very virtuous cycle as to our reasoning behind this position. If we think about why AI fuels the demand for more developers, let's start with what's happening currently, right? So you have developers who use AI to build better software, and they do it at a much faster cadence. So what happens as a result? You'll find that even today, this is not new, this is not specific to AI, but software delivers every organization a very strong moat. So in fact, software has become a synonym for providing a competitive edge, right? So as software increasingly provides greater and greater competitive edge, AI is going to democratize and in fact commoditize a lot of the existing competitive edge, which means the nature of software has to evolve to maintain and sustain that competitive edge. Which also means if you have to continuously build differentiated software, you need more demand. There's going to be more demand for differentiated software. Plus, who's going to build this kind of differentiated software? It's going to be humans, it's the developers. So which really clearly illustrates that with AI, you're going to see demand for software developers increasing, just not incrementally, but exponentially. The only folks who actually say that AI decreases the demand for software developers are the ones, and pay attention to this, are the ones that don't see software as being a core differentiator for their organization. If you believe that you have stagnated with software development in your organization, yes, of course you don't need more developers. Do we have a precedent for this? Yes, we do. Jevons paradox has been historically a great precedent. Anytime you have a resource, being consumed more efficiently, when the consumption of a resource becomes more efficient, it has never historically decreased the utility or usage of that resource. It's almost always gone up. If you think about fuel consumption, as cars have become more fuel efficient, the overall consumption of fuel and of course the number of cars have gone up. And very, very clearly you sort of draw this line of reasoning that as software engineering teams become AI native, developers become more productive, you have greater demand for more software and developers, which also means you'll need more software engineers. The next position we take on how we work is on developer creativity. This is again also going counter to the grain, where everyone is super obsessed about developer productivity. We believe that in fact it is developer creativity and not productivity that's going to be the yardstick for engineering excellence. Okay. And in fact, if you think about this focus shifting from productivity to creativity, think of this as, in many ways, why is this shift happening? Productivity is a laudable goal if we optimize against a known and stable set of variables. But that really breaks down if we have to continuously respond to a shifting and changing environments. Then it's creativity rather than productivity that should become our central competence, right? So this is actually at the heart of, if you go back to what I said a couple slides before, with software being a competitive edge, no company has derived a competitive edge through productivity alone. If we look at all the iPhones in your hands, the iPhone did not result from Apple engineers becoming more productive. It was somebody's creative genius, right? And what happens when we value developer creativity? We are able to solve problems that we couldn't solve before, right? This is pretty like a logical extension. In fact, it's also going to have a dramatic impact on the nature of hiring. We're going to hire for the ability to learn, for the ability to acquire skills, rather than looking for proven skills. You'll no longer have job descriptions that cite any programming language, because programming languages languages are going to be automated. The art of programming or syntax is going to be commoditized. You're going to really expect engineers to pick up anything on the fly, right? So ability to learn. This is my most favorite one, which is people are going to start using AI for leverage, not merely for going faster, right? So think of AI as a leverage point. Again, one of the very fascinating insights we've gleaned very recently is, think of what the role of humans is going to be. We're going to create increasingly more value on the fringes. What do I mean by this? If you think about what's happening today across different dimensions of work, AI will increasingly be doing a lot of the executional and transactional aspects of the work. So think of AI as being the executor of work, and where the request and response comes, this is where humans will increasingly play a role. So think of humans playing a much more important role in the pre-work stages. So think of this as humans making more important strategic decisions, also rethinking the problem, reframing the problem. So this is in fact I think colloquially we use the phrase as, are we building the product right, or are we building the right product? So humans will play a huge role in determining, are we building the right product? And again, on the response side, once AI has generated the response, humans will be involved. And this applies to every role on the team. We're going to be increasingly involved in reconfirming what AI has generated, plus also building trust, right? So with users, because humans trust other users, or humans trust other humans. How happy, all of us are when we see a human on the other end of the customer support call. You never like being directed to, nobody gets a smile saying, I'm going to direct you to a customer support agent or a bot, right? So you love to hear when someone actually picks up your phone. Right? AI impacts what we build. Now let's look at the impact on how the nature of applications is going to change. This comes as no surprise, because AI systems are becoming pervasive. In general, you're looking at AI agents not just being semi-autonomous, but autonomous in general. So which means that it's going to be increasingly easier to build software and also intelligent software, but it's going to be very difficult to earn trust. So in fact, like I mentioned at the beginning of this session, this is the single most biggest differentiator between intelligent applications and traditional applications. Traditional applications, of course, carried a lot of risk, but they never had this additional burden of having to earn trust, right? This is where intelligent systems carry this additional burden. If you look right here, we're saying, well, you have systems that are going to be intelligent by design, which means you need a technology stack, right? And so at every layer of the technology stack, if we have to infuse trust, what we need is responsible AI practices infused across all of these layers of the technology stack, which leads to a logical sort of conclusion, which is you also need to complement your technology stack with a corresponding trust stack. And this is where it becomes increasingly important, right, to just build trust. In fact, I also think of this as, if you look right from the foundational layers of the trust stack all the way upwards, you're also looking at how accountability becomes increasingly important. In fact, even as whether AI is generating code or you're building intelligent applications, the accountability factor does not shift. Accountability still stays with humans. Accountability still stays with organizations. So this is one important takeaway for all of us in this room, is even as we build applications that are intelligent by design, we need to make sure that they are trustworthy by design, and that requires humans and organizations still to assume accountability for what we are building. Right? Well, this is nice in theory. How are we going to operationalize responsible AI practices? This is where evals come into play. So in fact, I think it was Greg Brockman, he famously said, evals are all you need, right? So as a sort of an extension to attention is all you need. So think of evaluations as the modern equivalent of tests, right? So in fact, eval-driven development becomes the new test-driven development. The reason we explicitly are focused or should be using eval-driven development is because, much like application security, right, you don't infuse or you don't bolt on security at the end of the development lifecycle. Now, likewise, the reason we say eval-driven development is because you want to first build evaluations to measure or define what success looks like, and then have that drive your development processes, which is why we call it eval-driven development. Also, the other sort of metaphor, if you're new to the term evals and you're wondering, how is this exactly different from tests? A very simple metaphor can come in handy. Think of tests as you testing a calculator application, for instance, right? So it has finite, it has deterministic logic. Every time you run the calculator app, 2 + 2 always gives you 4. There's no other answer. So it's the same output for the same input. Evals actually are designed for testing systems that don't necessarily behave the same way. So think of evals as you grading an essay, for instance, or you testing an application that in turn grades an essay. Guess what? Grading an essay is pretty subjective. There's no formulaic approach. For anyone in university, you'll completely agree. So if you write an essay, right, 2 different professors can grade the essay in the same essay and give them 2 very different grades for very justifiable reasons. Now, how do you implement eval-driven development? So Gartner is tracking an emerging market which we call AI evals and observability platforms. A very interesting insight for you is that think of evals as being offline, but observability is where you can apply those evals as runtime guardrails. Okay, so this is where these are the platforms that will blend in evaluations and observability together. So in fact, I'm working on this market myself. I've been tracking up close to about 40 startups, including established companies, building AI evaluation and observability platforms. A few that just come off the top. Aries AI is a popular one. Brain Trust, Confident AI, right, who has the deep eval, open source, like, and so many, Galileo, and so on and on. The other technology which we commonly encounter for integrating responsible AI practices into applications are AI gateways. So in fact, you don't have to look far for who the AI gateways are. Almost every single API gateway that you see on this sponsorship chart is going to provide an AI gateway in future. So think of this as the evolution of API gateways. So I look at API gateways as a central policy enforcement point for enforcing a lot of your trust practices, security practices, cost visibility, reliability practices, and so on. It's a very interesting chart. So if you think about this, much like what AWS did to abstract away infrastructure complexity, we believe that internal platform engineering teams are going to do the same for abstracting away the complexity of building intelligent applications. In fact, there's a need for this. So the reason I say platform teams, where did platform teams suddenly come from? Everything that I described so far, whether it is responsible AI practices, providing cost visibility, ensuring reliability, and all of the non-functional characteristics, you don't want to leave that to the discretion of every application team. If you want to build in consistency, provide sort of a layer that abstracts away most of the complexity to implement this, you do want to engage your platform engineering teams in your organizations. So think of platform teams as providing intelligence as a service. So this is the new IaaS, right? So the new IaaS becomes intelligence as a service provided by platform teams to all of the other application teams across the organization. And you can clearly see the three-layered stack here for the internal developer platforms. So you have models, you have engineering tools, you have apps, right? So almost this is going to vary across different organizations, but roughly this is sort of, think of this as the blueprint or the reference architecture for an intelligent, as an intelligent developer platform or an internal developer platform. Lastly, now we are going to look at the impact of AI on how we build software. So far we have seen the impact on how we work, what we build, and it's going to change how we build as well. Okay. Let's look at a future direction. One, of course, vibe coding has caught everybody's attention. Back when I used to code, and coding was my day job. Okay, I still code, but now coding is my night job. And my code doesn't work, and I have no idea why, was my common refrain, right? So this is literally me when coding was my day job. And if you look now when coding is my night job, I'm really looking at vibe coding as my code works, right? But I have no idea why. Okay, but despite all of these productivity gains, even for, I'd say right now, a non-professional programmer, despite all of this productivity, why are we not seeing the organization become more productive? So we hear this from engineering leaders all the time. Everyone says, my developers are productive, but my teams are not. What gives? Can you please explain this? It's pretty simple if you think about this, and every engineer knows this. It's not bubbling up to the sea level, right? Coding was never really the bottleneck, which is clearly what is being illustrated here. If you look at this spectrum of SDLC activities, you're clearly looking at coding being a very small sliver across the full software delivery value stream. And regardless of whether you get 20 or 40%, my screen just went blank here, please. So regardless of whether you get 20 or 40% productivity improvement, and if average developer is spending just 10% of their time on coding, do the math, you get roughly 2 to 4% overall productivity improvement. So which is what you start seeing now. In the last 6 months to 1 year, we've started seeing a dramatic shift where it's no longer just about AI code assistants primarily focused on the coding phase, but you're starting to see the use of AI across every phase of the development lifecycle. You can start to see this emerge in the planning phase, where you're basically looking at AI as helping with activities like threat modeling, which nobody thought of this as a use case even 2 years ago, right? In fact, of course, everyone uses AI pretty regularly. You're almost seeing this as being an upstream use case as well as a downstream use case. I'd like to think that, in fact, if leaders want to maximize the utility and the benefits of AI, realize the maximum return on investment from your AI investments, the best way you can do this is to, first of all, map your full software delivery value stream, identify where the real constraints, the bottlenecks are, and then apply AI across all phases of the development lifecycle. But it doesn't stop there. When I say apply AI at all phases, we also mean it's not just like operational efficiency, like I have on this chart. So on one end, it's of course enhancing software delivery efficiency, which is the y-axis, but you also want to look at different personas on the team, which is the x-axis. So improving developer experience, and this role could be, we did case studies with many companies like CBRE, who is in real estate, Vizient, who is in healthcare professional services companies. Almost all of them are starting to think of AI as an augmentation device for all roles on the engineering team. It's no longer just a developer-centric tool. So the road ahead, and we're coming to the close, is one, what do we see as potential pitfalls, and what do you want to overcome? Think of security as being one of the biggest concerns for both security organizations as well as engineering organizations. We believe that if we really want to achieve this nirvana of zero friction software delivery, we have to ensure that security must cope with the exponential pace of development. So you don't want security to lag behind. So this is extremely important. The other thing is also looking at agents. Let's not discount the value of agents. What you're starting to see is agents enable acceleration. Agents help activities to be performed in parallel, which is where the word async comes from, right? So a lot of tasks in future, engineering tasks, are going to be done asynchronously. So developers might be working on future enhancements. Agents will be asynchronously working on bugs that exist in past releases. So it's a lot of async work going on. And of course, the pinnacle is autonomous SDLC. Context layer becomes the new innovation surface. So I think this is extremely interesting time if you are building tools to help developers, because a lot of innovation, of course, is happening at the model layer. And as the model providers are sort of encroaching upon the experience layer, you're starting to see that the biggest gap that exists today in software engineering tools is the lack of context. So in fact, as you start using multi-agent systems, being able to pass context from one agent to another, I think is a big gap, plus also a huge opportunity. Lastly, I think one of the biggest areas of innovation and where innovation has probably lacked so far is, and if you want to compare agents to how junior developers work, and they're not equal. Think of this, junior developers actually internalize what they learn. If you tell them, hey, you made a mistake, right? They're not, you can rest assured they're not going to make the same mistake again and again and again. If you think of models, they don't behave the same way. Models don't internalize. So every day is day one on the job for models. So every day it's almost like they're starting from scratch. So this is, in fact, I'd say one of the big downsides of agentic systems. So we have not yet reached a point where models, and by extension AI, agentic environments are self-optimizing and self-evolving. Okay. So if we were to resolve all of these concerns, what you end up is with an environment, a development environment that enables zero friction SDLC that will help you convert your intent to an outcome, which means that building products are going to be as simple as just firing up a Google Doc, right? So with that, I want to go back to the original question and wonder if the answer has changed now that you have heard us talk about all of this. What would you build if you could build anything? I want to leave you with that question. Maybe by the end of API Days, you might again have a different answer. Thank you for your attention, and thanks everyone.